Okay, here we go. Here's what I get super excited about. The super cool features of sewage treatment. And this is actually really cool. Let's just quickly review what we've got going on here. So the outputs of sewage treatment so far was we got some stuff that goes into a landfill, right? Garbage. And we still have this heavy stuff to put in a landfill. And we've got the settling tank. These are kind of organic solids that have to go in the landfill. So let's write landfill. I'm just that's just review. What can we do with these things instead of putting them in the landfill? This settling tank right here, like I said, this could go in the landfill. And that's where it went up until not that long ago. But it is organic. And so this stuff and this stuff can go into a different process. That's pretty useful. So these are arrows. We can put it in this big box here. It's been already digested. This has been digested by aerobic bacteria. But we can take this and put the waste that comes at the bottom of both these tanks, and we can put it in an anaerobic digester. An anaerobic digester actually takes that organic material and breaks it down even further. But since it's doing it anaerobically, it's not going to have CO2 come out. Right? What happens when you have an anaerobic digester break things down is it ends up making methane. Right? It uses hydrogens instead of oxygen. So this is methane. And what can we do with methane? Well, with methane, we can burn the methane to make electricity. Now that's pretty cool because if we can then, this takes a lot of electricity to run this plant. But if we can capture some of this waste and capture that energy, make our own electricity, some of the electricity can go back into the plant. Because that's what the bacteria are doing. They are, we're giving them all this sewage because they're getting energy from it. So it'd be great if we can get some of that energy back ourselves. So one thing I forgot to mention is instead of putting these in a settling tank, this stuff hasn't even been broken down biologically yet. So this stuff is so nasty. We're either going to have to put that into the dump or we can have to put it in an anaerobic digester. This has been broken down. So this stuff, instead of putting it in a landfill, and maybe instead of even putting it in the anaerobic digester, we could use this as fertilizer. Fertilizer. Now it still has some bacteria. Okay, so not on food crops. We're not going to want to put these on food crops, okay? So, but here we've got rid of all these solids because the only thing that comes out now is electricity and methane gas. If we have a little bit of stuff that comes out of this that isn't methane, this stuff had been anaerobically digested. This is great fertilizer because it's been anaerobically digested. So now we're being much more like nature, and we're using all of the waste, right? So let's go back over here though, because here's some problems. So the salts, I don't know what we do with the salts. Salts are almost impossible to get rid of, but they're not so bad. So those we're just going to have to keep in there. But we know that the nitrogen is a problem. Why is the nitrogen a problem? Well, the nitrogen is a problem because it makes eutrophic areas. Why? Because it makes algae bloom. Why don't we feed this to some algae in a pond? If we take this effluent that comes out and we put it into a pond, right, with green algae, the green algae is going to use up the nitrogen, right? And what's going to end up over here is clean water. And then we can do something with this green algae, maybe making that into fertilizer, or maybe we can harvest it to make oil. But we're basically getting some free nitrogen. We might as well use it. Now, even if we don't end up using this, this could be a little wildlife habitat. Right? So since we know we got excess nitrogen, let's put it into a little pond that will keep the nitrogen in one spot, and then the plants and algae will use up all the nitrogen, and we end up with clean water here. So we still have the pharmaceuticals, and I even have a place for the pharmaceuticals. This is what the pharmaceuticals are good for. Your college thesis, right? So this is a problem. We don't know how to deal with these pharmaceuticals. It's better not to put them in the system in the beginning, but if we put them in our bodies, they're going to come into the system anyway. How are we going to deal with these? So one of you is going to have, maybe we can capture them and put them back into pills, but that is a problem, and I hope one of you can figure that out. So let's look at the outputs of sewage treatment now. We put in garbage, which is a problem, right? We put in garbage, which is a problem. We have to take out the big stuff in the landfill. So I'm going to under that line in, this is bad stuff, right? So what we could do is just not put those things in there to begin with. But everything else, the methane and the electricity, we get methane out of this anaerobic digester to make electricity, or maybe what comes out of that digester, we get a little fertilizer. Here we've got fertilizer. We can use that sludge in a couple ways. Don't put it in the landfill. And over here we end up with clean water for agriculture, or in the environment. We end up getting rid of the NO3. Maybe we end up with some wildlife habitat, and you get a college thesis out of it too. So that is the super cool aspects of sewage treatment. I hope you thought that was really interesting. To me, it really embodies a way that we clean water, sort of that mimics natural systems. We just kind of speed it up.